Hello everyone. So let's just go over all of the parts of the free response from 2011. Okay, so I know we went over part A and part D in class, but I figured I would just go over this again for you guys, especially since we're going to use part of part A for part B. So for part A, if I want to find g of negative 3, I'm going to look at my, information that I'm given. So I'm given... Let's see, what am I given? I'm given the graph of f. And then I'm also given that the graph of f consists of two quarter circles, right? So that might be helpful for us, just because maybe using the quarter circles might be useful for area or something like that with integration. And then I'm also given the function g. So I'm given g of x. Right, and I did skip over this part here, but it's important to note that the function f is continuous, okay? However, it does not say that it's differentiable. So the graph of f is continuous. From -4 to 3. And then we know that g of x is equal to 2x plus the integral from 0 to x of f of t dt. And so the fact that we see from 0 to x, like this part right here, this is indicating to me that I'm probably going to use the fundamental theorem of calculus part 2, where we talked about the derivative of the integral. Okay, so there was two parts to that, so make sure you're aware of what I'm talking about when I say that. Okay, so now I can finally really attack the question. So it says find g of -3. So I know that I know what g of x is, so wherever I see x, I'm going to plug in -3. So g of -3 is equal to 2 times -3 plus, and don't let this integral fool you, but we see that it's from 0 to x, so this is really from 0 to -3 of f of t dt. Now what looks a little funny about this is that we have that this is the integral from 0 to -3 instead of from -3 to 0, right? So remember, we typically want the smaller number at the bottom and the bigger one at the top. So we're going to use that property of integrals to flip the bounds, right? So this will become 2 times -3, which is -6, minus the integral from -3 to 0, f of t dt. And now we have to look back at what we have in terms of actually finding this integral from -3 to 0 of f. So since we have the graph of f, right, we don't have the function f. If we did have the function f, then we would just find the, an antiderivative and plug in the bounds. But since we have the graph, we need to find the area between the curve and the x-axis. So since we have the graph of f, find the area between curve and x-axis. Okay, so by doing that, I get that this is -6 minus, and now I'm trying to find this area right here shaded from -3 to 0. And so that's why it was important, right, that it told us that f consists of two quarter circles, so that when you're looking at this curve, you know exactly what this is. This is a quarter of a circle centered at 0. So the radius here would be 3, right? So r is 3. Remember, the area of a circle is pi r squared. So this is going to be 3 squared pi over 4. Okay. And then you could leave it as that, but for the sake of this, I'll just say that this is 9 pi over 4. Okay, so now the second part says find the derivative of g. Okay, and so that's why I said over here, when you saw the integral from 0 to x and not 0 to a number, that you are probably going to use the fundamental theorem of calculus part 2 to find the derivative of that integral. So g prime of x is equal to the derivative with respect to x of 2x plus the integral from 0 to x of f of t dt. And we know the derivative of 2x is just 2, plus, now the question is, what's the derivative of the integral, right? So we know the integral is the antiderivative. So intuitively, when we're thinking about the derivative of the antiderivative, we should be back at the beginning of the original function, right? But we do want to be careful that that does work like that because of this fact that it's just 0 to x. Okay, so just to show you how we wrote this before, this was the derivative of, big F, the antiderivative. You don't need to show this on the AP exam, this step. Okay, because generally speaking, you're going to do this in your head, but this is just me explaining to you, right, that if I have big F, little f, f prime, right, that if I'm finding the derivative of big F, I'm going to be back at little f. So that's what I'm doing right here. I'm defining the derivative of big F, so I'm back at little f. Okay, so this is just going to be 2 plus, and the input is x, right? So this is plus f of x. So ultimately, this is what you could just write on your paper, that g prime is 2 plus f of x. Okay? And that would give you the point. You wouldn't need any of these steps, to be honest with you. Not needed. This is also not needed. Okay, however, if you showed some of these steps out, that wouldn't be wrong. Okay, but in general, for time purposes, I'm sure you're gonna look at this and want to just say that g prime is equal to 2 plus f of x, and you know what I mean, not write all these steps out, because this is timed. Okay, so then I'm gonna plug in -3 for the derivative. So I get g prime of -3 is equal to 2 plus f of -3. So this is 2 plus, and then I go to the graph to find f of -3, which is 0. So I get 2 plus 0, which is 2. Okay, and as we talked about in class, this was worth 3 points, so we're almost there to our goal of 4 points out of 9 for a 3 on the AP exam. And of course, you're aiming for on an average of 6 out of 9 for a 5. So anywhere in between 4 and 6, so it would be like 4 range. But anyway. So now I'm going to determine the x-coordinate of the point at which g has an absolute max on the interval from -4 to 3. And you need to justify your answer. So when you're finding the absolute max and min, so I'll write that over here. So for absolute max / min, here's our steps here. We want to find the critical points for the function. Which means that this is when, aka this is when the derivative is equal to 0 or undefined. Okay. And then we want to find the biggest and smallest value. So let's see. So what we want to do is we want to plug in the endpoints and critical points that lie within the interval back into the original function. And then lowest is the min, highest is the max. Okay, so yeah, so this is our procedure for finding absolute max and min, and it's going to be the exact same thing every single time. College Board, on their scoring guidelines, they give other explanations or reasoning for it that's also accurate. However, it's just not the same process every single time. So when you're practicing this, you want to be able to just look at absolute max and min, and especially in a time setting, not really think too deeply about it, right? You just want to go right to, okay, I need to find the critical points. I need to, plug in my critical points that lie within the interval and the endpoints back into the original. Highest, max, lowest, min. Make it, more simpler. The most simple. Okay, so I need to actually find the critical points for G. So I need to find when G prime is equal to 0. So G prime of x is equal to 2 plus f of x, right? So 2 plus f of x is equal to 0 when f of x is equal to -2. Okay, so all I did there is I set g prime of x equal to 0, and when I got to that point, I'm like, this is kind of weird because it's like 2 plus f of x, right? But if I solve for f of x, I can kind of figure out, using the graph of f, when f of x is equal to -2. Okay, so it looks like, looking for this intersection point, so it looks like at 2.5, right? So, which means that x is equal to 2.5 or 5/2. Okay, same thing. So g prime of x is equal to 0 when x is equal to 5/2. Okay, so if you write that on your paper, I'm 99% sure that College Board, and you can check in your own scoring guidelines because you have them with you, that this is worth 2 out of 3 points. Okay, so just finding the critical points and writing this down. Okay. So now, from here, I have to look at my interval that it wants me to find the absolute max, right? So I just have to ask myself if 2.5 is in between that interval, which it is. So I'm going to consider g of, is it -3 for the endpoint? Oh, -4. So I need to figure out g of -4, g of 5/2, and then g of 3. And then I'm looking for the biggest value. Okay, so g of -4, just going back to how g of x was defined, this is 2 times -4 plus the integral from 0 to -4 of f of t dt. This is going to be 2 times 5/2 plus the integral from 0 to 5/2 f of t dt. And then this is going to be 2 times 3 plus the integral from 0 to 3 of f of t dt. Okay, so yeah, so this part is going to take a a little bit. But hopefully you guys wrote this part down. If not, you can go back and rewind in your video. So I'm deleting it because I need space. Okay. So from here, what I want to do is, again, flip these bounds. So this is going to become -8 minus the integral from -4 to 0 of f of t dt. And I want to use the graph to actually find this integral. So from 0 to -4. Or from -4 to 0, I should say, right? Because we switched it. So from -4 to 0. So I already found from -3 to 0. So now I'm also just finding this quarter circle here and adding it to it. So this area, it looks like the radius is 1. So this is going to be pi over 4. But remember, because it's below, this is actually negative pi over 4. Okay, within the integral. So I'm going to have negative pi over 4. So -8 minus negative pi over 4 plus 9 pi over 4. Okay, because remember we found earlier this area right here that this was 9 pi over 4. Okay. And then this is going to give me -8 minus 8 pi over 4. So this is -8 minus 2 pi. Okay, and this is probably not going to be the highest because this is going to be approximately a negative number, right? It's going to be -8. Yeah, it's definitely going to be a negative number. So probably not going to be the highest, but we have to look at these other ones. So from 0 to 5 halves, now I want to find this area. So from 0 to 1.5, and then going this way, I got to find this area of this triangle. Okay. So let's see. So it looks like I have 2 triangles. So now this is going to be 1.5, and then the height is 3. So this is going to be 5 plus the integral of 1/2 times 3 halves times 3. And then I know that this is going to be minus because this triangle is below the x-axis. So it looks like the base of it is 1. And then the height here is 2. So this is times 1/2 times 1 times 2. And when I simplify this, I get 5 plus 9 over 4 minus 1. So this is going to give me this is going to give me 5 plus 5 over 4, which is going to give me 6 1/4. 6.25. Okay. And so now, what I want to do from here is, let's see. So now I just want to find the integral from 0 to 3. So I get 6 plus, and now I'm going back to the integral from 0 to 3. So I'm going to adjust this one a little bit. So now I'm finding this integral. And what's cool about this one is that it looks like this is the exact same triangle as the one on the left from 0 to 1/2, because the base and the height are the exact same. So they're going to cancel each other out. Okay, so I mean, I could write this down, but they're going to be the exact same thing, so this ultimately should just be 0. Because this is like 1/2, 3/2 times 3 minus 1/2 times 3/2 times 3. So you get that this is 6 plus 0, which is 6. Okay. So the coordinate where there's an absolute max is at x equals 5/2. Because the highest is 6.25.